Tube life, again, now we are focusing on the process of the cathode emission. So what does it mean and how does it impact tube operation, tube life, and what we can do to improve it? So cathode emission is basically the bread and butter of tube operation and of tube life and longevity. So far we have talked about the filaments, which is required to heat up the cathode, but it's really everything that happens in the vacuum tube is about the cathode itself. And when you look at it, the cathode, let's just draw it now as a wire. So if it's a direct heated tube, in that case the filament and the cathode are one and the same, and it is emitting electrons. So the electrons are flying off from the surface of your cathode, and that's called cathode emission. And the stronger the emission, the stronger your tube. So when you have a strong tube, it means that more electrons are flying off from the cathode surface when you apply the same voltage and the same grid voltage. So it means that it has a richer surface. So when it's a direct heated vacuum tube, they use thoriated filaments. Eventually there are some oxide filament direct heated tubes as well, but the vast majority is thoriated. So it means that that layer, or that metal that emits the electrons, it's a mixture of thorium and tungsten, and this wire, when it has a distribution of the thorium and tungsten atoms inside it, and when you have thorium atoms on the surface, those thorium atoms can release oxygen. I mean, not oxygen. I'm just tired. I'm sorry. I can't even speak. So the thorium atoms can emit electrons. The tungstens don't want to emit electrons. So even though it's still heated up to a high temperature, it won't emit electron. But the thorium will gladly emit. And now, when we have the barium oxide coating, there is the oxygen that likes to emit the electrons. And however, there's two fundamental differences between the oxide coated tubes, which the vast majority of the vacuum tubes are, and the thoriated filament tubes, which usually it's the older direct heated triodes and direct heated other tubes which are using such a filament. So in that case, the entire wire, which is the filament and the cathode itself, is made up and composed of this material that can emit electrons. In the case of the indirect heated filaments, there you have the same filament material and there's a cylinder around it, and it's coated with a few microns thick, really tiny layer that can emit electrons, and it's a very fragile layer, and once it's gone, it's gone. For the thoriated filaments, if the thorium molecules, thorium atoms, which are close to the surface, if they get depleted and they cannot release more electrons, then you can anneal the filament, which means apply voltage over it, heat it up without adding plate voltage to it. So here you would apply the plate voltage there. Do not apply plate voltage, just heat up the filament so the filament becomes hot. And if you look at the cross section of the filament, which is also the cathode itself, and it has a mixture of thorium and tungsten atoms inside, then as you add the heat to it, it's just like a skin effect. The thorium atoms will migrate towards the surface. And when they reach the surface, they will be able to emit electrons when you apply the plate voltage. And what Corey was asking in the video is, why does this happen before applying the plate voltage, and why applying the plate voltage stops this process? So what's the physics behind that? And here I'm going to show why that is happening. So this is a publication, thorium migrational effects on cathode temperature in electric thrusters. And when you look at the abstract, you can see the reason. So what's happening there? So it means that if you have a temperatures between 2300 to 2500 Kelvin at the cathode tip, and then there's a peak temperature between 2800 cathode at the close to it, and the minimum temperature of 2100 Kelvin, 20 millimeter away from the tip. And let me see what happens here. I'm sorry, I don't have my glasses on, so I cannot really read any of these to you guys, but I know what it says. And basically what that paper says is, once you have, let's stick with this cross section of our thoriated filament, and normally its temperature is around 2100 2300 degrees Celsius, so it's extremely hot. It's over twice as hot as the oxide filaments, and basically when you are heating up the filament, then you are fine. But when you apply an electric current on the plate, then what will happen is that because of that effect, that the plate is pulling electrons from your cathode, then the surface will be much hotter, and the inside of your filament will cool down. And because the inside is cooling down, that's why those atoms on the inside cannot migrate to the surface anymore. So this rejuvenation process that the thorium atoms are migrating to the surface stops once the plate starts attracting the electrons. And however, what you can do is that you are checking your tube and you see that the emission is going low, then just do not apply the plate voltage, just apply the filament voltage for an extended time, and it will rejuvenate the cathode. And it works for all tubes as well. So for example, if I have this tube here, and it's been sitting around for 70-80 years, and then I just turn it on, let the filament just heat up, and it will really increase the emission of the filament. So that's one thing. And also you can speed up that process if you just apply a few seconds burst at higher heating voltage. So for example, if your filament is 5 volts, apply 6.3 volts for a few seconds, maybe like 10 seconds, so that it melts a little bit more than usual, and you fasten this migration process, and then you let it cool down. But when you do that, never ever apply high voltage on it, because if you do, that will strip off your cathode and can damage it. For thoriated tubes, it's not so much of a problem, and eventually it might help to pull your thorium atoms to the surface. But if you try to do that process with an oxide cathode tube, the barium oxide coated cathode, in that process, if you heat it up to 20% hotter than what's the normal operation, and then apply high voltage, it will strip off that thin layer of barium oxide, and you will drastically decrease the emission. Basically, you will kill the tube if you do that. However, with these tubes, with the IDHTs, indirect heated tubes, you can still rejuvenate them by applying 20% higher voltage for half a minute or maybe even longer, but make sure never ever apply the high voltage when you do that. And if there was some extra capacity within the tube, you can still rejuvenate it. If not, then that tube is really getting weaker and ready to die. So I hope this helps a little bit, and if you like, then thank you. Bye bye.